Okay, this is part 2 of some rational equations that we're going to identify holes, vertical asymptotes, horizontal, oblique, or slant. Sometimes you call these slant. We call those slants sometimes. Y-intercepts, roots, domain, and range. And this video includes 3 rational equations. So the first one, by now you should already know how to determine if you have a horizontal or an oblique asymptote, and for the horizontal how that works. That we did that in section 3.3. And I'm going to go a little faster on part 2 than I did for part 1. So the first equation is here, and the first thing I'm going to notice while it's in this form is that I have a horizontal asymptote at y equals 3. And the reason I know that is my degrees are the same, so I take my lead coefficients here and divide them. So 6 divided by 2 is 3, and that gives me y equals 3. Now, I can't figure out my domain just by looking at this. So what I'm going to do at this point is factor both my numerator and my denominator. So I'm going to pull out a 6. When I pull out a 6, I'm going to get x squared minus 2x plus 1. And IB, this is called using the highest common factor, HCF. Alright, and then for my denominator, also, I'm going to go ahead and factor this more completely. This is really x minus 1 times x minus 1. It has the form of a squared minus 2ab plus b squared, which gives me this right here. Okay, the denominator is going to be, let me go back to red, 2x and we're going to have an x, probably minus 1, so this is going to be minus 1 as well. Let's see if this works. So that's, yes, that works. So right away we notice, let me write it over here, so 2x minus 1 times x minus 1. So right away we notice we have a hole, but before we do that, I'm going to state what my domain is. So my domain is, why did I do this? Okay, so this is a 3. I was looking at the top when I did this. So that's 3. My domain is all real numbers such that x cannot be 1 and x cannot be 3/2. Okay? Since I have a hole, that means I can cross these two out. My holes, or I only have one, is a point where x is 1, and I'm going to plug in 1 in my reduced. This is my reduced equation, or depressed equation. And when I plug in 1 in the numerator, it comes out 0, so that my hole is going to be at 1, 0. That means my vertical asymptote is only y equals 3/2. Okay, because it can't be 1 because there's a hole there. So my vertical asymptote goes here and here. Okay. I have a horizontal asymptote at y equals 3, so I do not have an oblique. So you're going to write non-applicable for that. Alright? And what else do we need to do? Since I have horizontal asymptote at y equals 3, that means my range is y cannot be 3. So you have your range is all reals, however it can't be 3, and also it can't be 0 because there's a hole there. So for my hole, for my domain, that part of the hole, this is my x and this is my y, I have to include this part in my range and domain. So I also have that y cannot be 0. Alright? Now, we have to find the roots. So I'm going to just use my depressed equation. And for my x-intercept, I let y be 0. So when y is 0, I have 0. Remember the denominator cancels out. Equals, for my, let me erase this real quick. So that means 0 equals 6 times x minus 1. So x has to be 1. So that would be 1, 0. And for my y-intercept, that means x is 0. I plug in x for 0 and I get, let me just do it over here. So when x is 0, I'm going to get, this is my equation now. And when x is 0, I'm going to have 6 times negative 1 over negative 3, which equals 2. So that is my y-intercept. And I'm going to go ahead and try to graph this. Let me just use graph this here. So when I graph it, I have my x-intercept at 1, 0. My y-intercept is at 0, 2. My vertical asymptote is at x equals 1/3. 1.5. My horizontal asymptote is at y equals 3. And it doesn't cross, but we don't need to know that, so there it is. Here, and then it's up in here, and then I'm going to run into that, what I just wrote on. So, it's something like that. Okay, the next equation we're going to do is, let me do this on white paper. So this is number 2. This is 9 minus x over x squared minus 4. If I factor the denominator, it's x minus 2 times x plus 2. I notice my domain is going to be x, such that x cannot be plus or minus 2. There's no holes, so for holes you're just going to write in non-applicable. Alright, and then for my horizontal asymptote, since the degree in the numerator is 1 less than the denominator, or basically smaller, it means y equals 0. And then for the range, I don't have to worry about holes, so that just means that my range is all y, such that y cannot be 0. So all y, but y cannot be 0. Okay, next thing we need to do is find the roots. The roots are, you set y to be 0, you just look at all you do is what would that, set that to 0, and you get x is 9, and y is 0. And when you want to find your y-intercept, we're going to let x be 0. So I just plug in 0 here, and I'm just going to write on top of this, that's a 0, That's a 0. So we get negative 9 over 4. Negative 9 over 4. And that's going to be your y-intercept. And did I leave anything else? Oblique asymptotes. Since we have a horizontal asymptote, for oblique, you're going to write non-applicable. Okay? And if you want, I can graph this real quick. I'll do this. We have a root at 9, 0. 1, 2, 3, 4. Whoops, 3, 4, 5, 6, 7, 8, 9. 9 is there. Let me make it big because I made a mistake there. And, oh, y-intercept at negative 9, 4. So it's a little bigger than negative 2. I'll just put it here. Somewhere here. I have 2 vertical asymptotes right here at negative 2, x equals negative 2, and x equals 2. And I have a horizontal asymptote at y equals 0 right in there. Now in this case, I'm going to draw it, it goes this way. Something like that. It's just a sketch. It's not perfect. And there's the y-intercept in there. And from here, especially since I have this x-intercept here, or root, it does cross the horizontal asymptote. And I just want you to know that it crosses. When you get in calculus, you might run into that. Okay? The last problem we're going to do is this one. Go back to white. 2x squared f of x equals 2x squared minus 3x minus 9 over x. Okay, right away I notice that my domain is x. However, x cannot be 0. I have no holes, so I'm going to write non-applicable. There's nothing I can cross out with the x. I can't factor out an x in the numerator. So my degree in my numerator is higher, 1 higher than my degree in the denominator. So I'm going to have an oblique asymptote. My horizontal asymptote I don't have. I'm going to have an oblique. I'll just have to use long division here. Since I have an oblique, we're not going to worry about the range, even though there is one. So I'm going to write non-applicable. And we'll do the y-intercept and stuff later. So I'm going to go ahead and factor the numerator. And I'm going to get 2x plus 3 times x minus 3 over x. And when I do that, I notice that my horizontal my roots are going to be when y is 0, x is negative 3/2, and also when y is 0, x is 3. Notice with the y-intercept, however, that's when x is 0. So when you look at the y-intercept, when x is 0, we can't divide by 0. So in this case, we do not have a y-intercept because you can't divide by 0. So there is no y-intercept. Now when I figure out my oblique asymptote, what I'm going to do is use long division. I'm not going to use this one. I'm going to use this. So we'll go to the next page and we're going to divide 2x squared minus 3x minus 9 by x. And when you do that, you can get 2x, and you multiply this by 2x squared. That is 0. Bring down the negative 3x. So that's going to be minus 3. You get negative 3x, and that zeroes out. Once I have my linear term, I don't need to continue on. You do have this little cast off with the 9, but we don't need that. So my oblique asymptote is y equals 2x minus 3. And for a quick sketch of the graph, let's go to the next page. I'm going to graph my oblique asymptote, which is 2x minus 3. The y-intercept is negative 3. Go up 2 over 1, up 2 over 1, down 2 over 1. So kind of get that in there. Something like that. It's hard to draw on the iPad. Okay, so there it is. Now I have a x-intercept at negative 3/2, which is about there, and also at 3, which is about there, and I have no y-intercept. So this is what this, oh, I also have a vertical asymptote at x equals 0, so this is this little bit in here. You can't cross the vertical. Now, it looks something like this. And what I want you to notice here is, without graphing it, which you don't have to do, it is hard to determine the range. That's why when you have an oblique asymptote, I told you for the range, you're just going to write non-applicable. So basically what that's saying is you don't have to worry about it. You won't be graded on it. Okay? Part 3 is going to be 2 more examples. And if you know these 7 examples, you should do well on your quiz.